Hi all, in this lesson we are going to consolidate our understanding again on sketching sine and cosine graphs with dilation. Let's have a look at the theory part quickly. If I have any form of these for our circular functions, the negative means it's reflected through the x-axis, and also A means the dilation or the amplitude, that's how far you are away from the x-axis, and the n, that matters for the period. So if n is 1, I would have one full cycle in the full period, which is 2 pi. But if n is 2, then I would have 2 cycles. What does that mean? 2 cycles mean we have period half what we had before, which means 2 pi on 2, which is basically pi. Let's carry over that one into our first graphing here. It says 3 sine x on 2. Now in this case 3 means the amplitude is 3, therefore the function fluctuate between -3 and 3. I have given you the base one that we are starting off, which is in that color is sine x times by 3. So simply 3 sine x. Now when we have x on 2 instead of x, what it means is for us period for this particular graph is 2 pi over n. Now in this case n is in fact half, so you really need to write down this as half x rather than x on 2. Therefore if I put half in there, I would get 4 pi. So 2 pi divided by half is 4 pi. Well, what it means for us, we get one full cycle in 4 pi. Therefore halfway between 4 pi is 2 pi. The top part is reaching to 3 halfway through of 0 and 2 pi, which is pi. Now we are simply working through to get that graph, and then the other part is just here, and then complete my cycle for that. In this case period is 4 pi. Now we've been given we have to sketch to the left too. What it basically says is when I look at x on 2, the graph has stretched away from the y-axis and twice as the distance, simply stretching by 2, and that's my x-axis. Well, into the left again the same manner, we go down to -3 halfway between -2 pi and 0, and then the hump here reaching maximum 3 at -3 pi. So that's my full cycle for this graph into the left. Now we have done that. Okay, now we are stretching by factor 2 if it is 1 on 2. If it is 1 on 3, by factor 3. So you're going away from the y-axis. Let's have a look at another one. This is one is squashing. Now when we squeeze by 2, the period is 2 pi over n. Here n is 2, hence becomes pi. So in 1 pi, just in here, I would have this cycle done. What it means for us, okay, the hump here is squashed by halfway through. This is pi on 2. Therefore it moved to pi on 4 here. Therefore I get a graph like that. The base graph here, of course, in green is 2 sine x. I'm going to squeeze that one now. Hence the bottom part becomes like that. Therefore up to pi I would have one cycle into the right, and also to the left hand side for up to negative or down to -pi I would have another cycle. So it should go down and then hit the minimum and then come back. That's a bit bad. Let me do that again. or rather this way. It's much better. And then the hump is that way. Okay, so that's our graph for 2 sine 2x between negative pi and pi. Of course, there are x-intercepts. We will be writing them, so that will be negative pi on 2 comma 0, and this is negative pi comma 0, and that's pi on 2 comma 0, that's pi comma 0. Righty, the maximum is still 2 and minimum is negative 2, just in here. Right, let's have a look at this one. This is a little different, the dilation factor in terms of pi now. Let's calculate the period. 2 pi on n. My n is now pi, hence answer is 2. So the full period is 2. What it means is I have to do full cycle and then finish off at 2. That's what it is. In this case it is cos. Of course you got to start on the top and then down and finish off like that. So let's try to get this one pretty neatly. We're starting at 3 because the amplitude is 3. Therefore we got to start here, and then the minimum 3 occurs halfway between, which is negative 3 minimum value, in fact. So you go down halfway in the middle here, 1 halfway is here, and then between 1 and 2 it's 1.5 there. Therefore I would have a graph that goes through that and then down to negative 3, coming up and then hit that value and then reaching the max there. So if I were to do this one for few times, I actually have to change this interval. That's not correct. Let me say negative 2 to 2. I need to change that. That's good. Negative 2 to 2. I done up to 2 now. If I did up to 4, it would repeat like that, like this. Down. It's a little off. Okay, down here up to negative 3 and then coming up and then reaching again maximum at 4. And let's complete to the left hand side. Same manner, at negative 2 I would have the max, at negative 1 I would have the min, because it's repeating that way, like that. Let's complete. It's easier for me to sketch from this point onwards, depending on how you feel your sketch, but make sure that you get a nice smooth graph like this. And even if I went a bit further back, at negative 3 I would have my minimum value again here. Therefore I should have come like that, and then if I kept completing this one, I would hit at 4 I would hit the max, which is somewhere there, and then halfway through I'm down to the 0. So likewise, so you can simply complete the cycles up to either negative 2 to 2 or negative 4 to 4. Either way, understanding here is the period is 2, therefore it repeats every 2 units, in this case for y over x-axis. Cool. I think that's all from me for this part, and I'll catch you again on the next bit where we are going to translate these graphs, moving up or translating each graph in the positive direction or negative direction of the y-axis, as well as positive and negative direction of the x-axis. Okay, so let's move on to that one. Alrighty, here we are, sketching the graphs with translations. You can clearly see it's plus minus. Plus minus mean either you translate in the negative direction and positive direction, in this case for x-axis or the t-axis or the theta axis, whichever axis, or the independent variable. And then we are going to look at pushing up and down, which is translating into the positive and negative direction of the y-axis later. Let's do this first. Now I'm going to draw your knowledge or the skills that you have so far regarding functions. If I have a function f(x), then minus a, you translate a units to the right. So that means in the positive direction of the x-axis. Plus mean negative direction of the x-axis. Here it's negative, therefore in the positive direction of the x-axis, and you can clearly see I am not going to change anything here. It's just the amplitude 3 in there. It's already done. Base graph is always here. It's good to get a base graph with a dotted line for you and then rub that out later. This one is y equals 3 sine x. What I'm going to do is I'm going to translate this one in the positive direction of the x-axis by pi on 2 units. So plus pi on 2. Well, it's quite easy. You look at the major points here. 1 on the 0, 0 moves to pi on 2 comma 0 now. So that's where it should be now. And this one goes to there. This one goes to here by pi. The pi comma 0 is 3 pi on 2 comma 0. And then 2 pi comma 0 goes to 2 pi plus pi on 2, which is 5 pi on 2 comma 0. Well, that's where we got to finish. And at the same manner, you can think of, okay, the maximums move pi on 2 units. Therefore, that is our new one. I'm going to put a circle for the ones before. Oops, it went down. Sorry about that. Okay, this one should move to right by pi on 2 units. And this one should move to y-axis now. And this one should move to here, that point. Okay, let me write that first here. And then write down what I'm doing here. So basically pushing this one of pi on 2. So going to the right. Well, that's my y-axis, that's my x-axis. Let's try to push nicely, and also of course this point is in here now. Negative 3 pi on 2 comma 0. Now let's get these humps nicely. I have done this one between negative 2 pi to 2 pi. The questions in your test or the examination would say what to be done. Right, so let's simply sketch this one. Right, going up and then down. Of course, this point has moved to here, negative pi on 2 comma 0, and then down with the minimum, and then here again, and then you keep going until you finish. Oh, the doctor got a pretty smooth curve here. That's great. That's what you should be getting. Right, let's move on to the next one. In this case, a cos graph. I have started off with the 2 cos x graph. The one in here purple is 2 cos x graph. Well, it's plus pi on 4, therefore you have to move or translate by pi on 4 units. So simply moving to the left, translating to the left hand side. Let me pull a different color, maybe that one. Okay, that's what we are looking at, my fx. Every time what we have to do is I look at my major points here, 0 comma 2. What I'm going to do is I'm going to translate that pi on 4 units to the in the negative direction of the x-axis. Okay, here you can see this is negative pi on 2, then pi on 4 is halfway through. You can see the nice grid here is scaled. Therefore, that's the point here. So the point in here move to here. So simply moving to the left. Point there moves here, and then of course point here should have moved, should move to the value there. So that will be negative 9 pi on 4, or rather negative 2 pi minus pi on 4. Right, and also this one by pi on 4, this one by pi on 4, this one also by pi on 4. Okay, right, let's get the graph. You can see if I've been asked to sketch only between negative 2 pi and 2 pi, let's see how it's gonna work. Okay, let's sketch as I would normally do for this whole thing. But what I have to make sure is when it comes to consideration, this one's here, the limit that I've been given for my graph, I need to consider that. Now I can't stop here. This is in fact going down, isn't it? So it keeps repeating. So if I clearly do that, that should go down by that point. Likewise, okay, just in here. Now I need to stop there if I've been given 2 pi to negative 2 pi, or between 2 pi and negative 2 pi, which means I have to put endpoints, so-called endpoints. Okay, how to find these endpoints? Well, that's negative 2 pi. I need to find the endpoints. What I need to do is I have to sub those points into my function, simply finding f2 pi. So how to find f2 pi? 2 cos x is 2 pi, so 2 pi plus pi on 4, simply replacing x with a 2 pi here to find that value. Well, what is that? 2 cos 2 pi plus. Okay, now cos 2 pi plus mean, if I look at the unit circle, and if you remember that, simply working our way through here, if I did a full circle 2 pi, back onto the value a, remember the point a that we took on our x-axis. Now you go up pi on 4 units, which is that point, which means exactly same as pi on 4 figure, or the heights and the lengths are exactly the same. Hence this is same as cos pi on 4. What is cos pi on 4? Root 2 on 2. Therefore 2 times root 2 on 2. The final answer becomes then root 2. The 2 and a 2 get cancelled. Right, so the height here is root 2. It is just below 1.5, which is roughly alright in here, but you need to make sure that in a grid, if everything is given, you write down or you sketch nicely so that the value nicely comes down to that point. But you can in fact indicate that there nicely, and then you can circle. That's where the point is. 2 pi, at 2 pi height is root 2. Now have a look at on the left hand side for negative 2 pi then. So again here f of negative 2 pi is exactly same, is 2 cos negative 2 pi plus pi on 4. This becomes pretty familiar to us now. Negative 2 pi mean going clockwise 2 pi and then go anti-clockwise pi on 4. That's what it says. Go 1 revolution clockwise and then back again 45 degrees pi on 4. Where are you now? Exactly the same as pi on 4 figure as we seen earlier. Therefore the height and the length are exactly the same as 2 cos pi on 4, which means I would end up with 2 times root 2 on 2 is root 2. Hence here height also root 2. Well, you completed the graph, and also you can work on the y-intercept here, which will be at 0 when you put 2 cos 0 plus pi on 4, 2 cos 0 plus pi on 4, which is 2 cos pi on 4. Well, same as that one before root 2, isn't it? So you can do these ones in your head now. So 0 comma root 2. That's our y-intercept. We will look at how to find x-intercepts in our next video lesson. Let's move on to the next one. Right, so we're going to complete this one and then one more to finish off. If you carefully look at this one, the graph that is being given, it is in fact 2 sine 2x. If you notice here, the period is pi. Normally it is 2 pi. How to get pi from 2 pi with an n, where n has to be 2 now. Therefore, the graph that is being sketched here already is 2 sine 2x, and you can see the amplitude is 2 as well here. right? So that's y, and this is our x. Now what we are going to look at is we are going to look at translating this one. So this case we are translating pi on 3 units in the negative direction of the x-axis, pi on 3. Now I have splitted this axis or the number line in pi on 6s so that we know where to move to. So pi on 2 is basically 90 degrees. If you look at 90 degrees and you are translating pi on 3, 180 on 3, which is 60 degrees. So every time you go that way, 60 degrees. If you do simple maths, from 90 it becomes 30, which is pi on 6, the dot here. And that means that point move to left here. And then this point, again, same manner, just moves here. And you can see all the dots being given. That's for each respective point that has moved. So I did a bit of a work beforehand to make your life easier, right? And also, of course, this point has moved to left there, that point to there. Right, now let's simply sketch, simply moving this one into the left. So we need to get this hump move to the left at 2 here, somewhere in the middle, just right in there, and then that's there, and it goes down and come back, and then same manner here, likewise. Now you can see clearly a pretty cool graph that is being translated pi on 3 units left. Now you get the hang of that, and of course you can find the y-intercept here, simply subbing x equals 0. Now if I look at that one, 2 times sine 2, when x is 0, it's pi on 3. Now I want to look at 2 sine 2 pi on 3. Okay, what is 2 sine 2 pi on 3? If you use your symmetric property, that becomes simply 2 sine pi on 3, complementary. Hence we get, I should have put equal sign there. What is sine pi on 3? From your exact value table, it's root 3 on 2. Therefore this is 2 times root 3 on 2. When 2 cancels, I should move this one a bit to the right. Okay, nice. That's good. Sort of a magic here, isn't it? All right, root 3. Therefore, I get the height here as root 3. So it should be 0, root 3. Roughly about, this is a rough sketch anyway. That's roughly about, let me get that right then. 1.732. That's pretty good, isn't it? Okay, there you go, 1.732, which is root 3. You must leave the answers in exact form in this case, and also make sure that you label all the x-intercepts here. Just and then this one as well. Righty, so we got that through. The last question, find the equation of the image of y equals sine x. That's my base graph. We are going to do some transformations here, and then we are going to write down the final equation. So what are we doing here? Factor 6 from the y-axis, that means that fx the x value, and the dilation 3 from the x-axis. That means the amplitude is 3, and then sine, and then you have the value. So your dilation factor 6, hence it stretches. That's what it is. Therefore x on 6. One last one. The amplitude is same, 3 sine, but the dilation factor is flipped now. It's 1 on 6 in this case. Therefore you can write down, let me write nicely, 3 sine 6x, and you can clearly see the dilation factor is the one that comes under x, that affects the period of this function. Can be written as sine x on 1 on 6. That means your graph has been squashed by 6 times. What does that mean? You get one cycle here you will get 6 of them. That's what it is. It's been squeezed. Righty, I think you got the basic understanding of this one. Please work through your work plan, and I'll catch you in the next lesson where we are going to find the solution of trigonometric equations. Happy learning. Have a good one all. Bye.